So I just stumbled upon this project called Cuck, and it's totally reshaping how we think about Rust in GPU programming.
Wait, seriously. I didn't know Rust was being used for GPUs. What's the main idea behind Cuck?
Well, it's all about formal verification of Rust GPU kernels. They're translating Rust's intermediary representation into Coq.
Coq, that's interesting. Aren't we talking about a way to ensure that the GPU code is both safe and correct?
Exactly, it connects Rust's strong safety guarantees with the well-defined PTX execution model. But here's the kicker. There's no formal semantics for Rust's GPU subset yet.
Really? So they're building this from scratch? That seems pretty ambitious.
Right? They're focusing on defining operational semantics for a realistic subset of Rust's MIR. It's like creating a safety net for GPU programming.
But doesn't that assume a lot about how Rust semantics translate to GPU? I mean, isn't there a risk of oversimplifying?
True, but it's a pragmatic approach. They're stripping away some complexity to focus on key operations like memory loads and synchronization.
That makes sense. So how do they ensure that the mere operations line up correctly with the PTX model?
They've developed a memory model correspondence. If a MIR kernel is data race-free, the compiled PTX maintains that consistency.
That's a solid foundation. But what about the limitations? I imagine there must be challenges.
For sure, they're currently only dealing with global memory and shared memory scopes aren't modeled yet.
So no handling of bank conflicts or complex intrinsics yet. That's quite a gap in the scope.
Yep, and they're also working within a curated set of MIR statements, which limits what can be verified right now.
That's interesting. But I wonder, how does this relate to existing GPU frameworks or languages?
Great point. It essentially builds a formal bridge between Rust capabilities and established GPU execution models like NVIDIA's.
So it's not just theoretical. There's a practical implication for how we might write GPU code in Rust.
Exactly. They're even working on a prototype toolchain that automatically translates Rust code into Coq terms.
Wow, that's a big step towards verified compilation. What are some expected outcomes of this project?
They aim to produce a Coq formalization of Rust MIR semantics and a memory model correspondence theorem.
And they're even running case studies on CUDA benchmarks. That's a practical test of their work.
Yes, they're verifying barrier correctness and data flow soundness, big deals in GPU programming.
But since they're omitting ownership and lifetime reasoning for now, does that limit their verifications?
Definitely, that's a huge aspect of Rust that they plan to incorporate later, but it's tricky.
It sounds like they're laying the groundwork for something much more comprehensive.
Exactly. Once they integrate those features, we could see end-to-end proofs of safety for parallel programs.
That really opens the door for safer GPU programming in Rust. But what's the biggest implication of this work?
It could redefine how we think about verified compilation for GPU code. It's a massive step forward.
And it has the potential to influence how other languages approach parallel programming and verification.
Totally, it's exciting to think about the ripple effects this could have across different programming communities.
I wonder how quickly they can adapt the framework as new GPU programming models emerge.
That's a great point. Keeping up with advancements in hardware will be crucial for their ongoing relevance.
Plus, integrating new features into the framework could pose challenges in maintaining soundness.
Exactly, they'll need to navigate that carefully to ensure everything remains verified and safe.
This is such a fascinating blend of theory and practical application. I'm eager to see where it goes.
Me too, and it really makes me think about how much potential there is in formal verification.
Right? It raises questions about the future of programming safety and correctness, especially in parallel computing.
I wonder what other languages could benefit from a similar approach to verification.
That's a thought-provoking question. Imagine if we had verified semantics for even more systems languages.
Oh, absolutely. It could lead to a new era of safety in systems programming that's much more robust.
I'm curious about the feedback from the community on this project. Are they on board with these developments?
It seems like the response is mostly positive, especially given Rust's growing popularity. It's an exciting time.
Indeed, The implications for future generations of programmers could be monumental.
So, as we reflect on all this, what do you think the next big leap in GPU programming verification might be?
I think it might involve more automated tools that can streamline the verification process even further.
That would be amazing. The more accessible verification tools are, the safer code could become.
That's a key takeaway. Bridging the gap between safety and developer experience could drive adoption.
Absolutely. It's all about creating environments where safety isn't a trade-off against productivity.
And maybe, just maybe, one day we'll reach a point where verified code is the norm, not the exception.
I can only hope. It's journeys like this that keep pushing the boundaries of what's possible in programming.
Exactly. And the advancements in CUC are just the beginning of a much larger conversation about programming safety.